now. Okay, let's start in 4.6. Exponential and logarithmic equation. Exponential and logarithmic equations. For example, suppose we have number 14. We have done some basic already though. So that's why I can just go ahead to solving problems. And then in between, we'll pick up new ideas here and there. For example, number 14, negative 3 to the negative x equals to 81. Now this 81 happens to be base 3. So I will change that to 3 to some power. In this case, I believe 3 to the 4. And then using 1 to oneness, we get negative x equals to 4, x equals to negative 4. Now the question is, what happened if that 81, we change that 81 to something which is not base 3. Let's say I make it 80 instead. Now notice that this 80 is not base 3. Now then, what we will do is we will need to use logarithm. Okay, we change that to log form. Log base 3 of 80 equals to negative x. So x is equal to negative log base 3 of 80. Now, this is what we call exact form. You can say exact form is the form that we have right before we use calculator. Okay, now then if I want to use calculator to make it into decimal, then I do change of base, because our calculator has only base 10 and base e, right? Okay, so I have issue with the base 3 here, which is not 10, not e. To do change of base, let me change to base 10. So this is equal to negative log 80 over log 3. Now then you use your calculator. Okay, then you use your calculator. Now when you use your calculator, be careful that usually after you press log, it starts with parentheses. Now then you will type 80. Make sure you close that parenthesis. Okay. If your calculator allow various spaces, I still want you to write it in. How to say? I usually ask that you give the exact form first, and then use calculator. Okay, now when you use calculator, then go ahead with whatever base you have. Okay, yeah, log 80 and then divide it by log 3 with, of course, with the negative sign in front of that. Okay, now on my computer, I have the emulator for TI-84. So you try to use your own calculator, by the way, okay, to compute that. Try to use your own calculator to compute that to get what we call approximate form. Now, let's see. Let me see if I share with you. Okay. This is my TI-84 in my computer. Now, suppose I want to compute that negative log base 3 of 80. I will punch negative and then log. Now notice that we have parentheses right away. Okay, 80. Now close the parentheses. You need to close the parentheses. Okay, and then divide it by log 3. I get negative 3.98869. Negative 3.98869. Let me go back to our notes. That is equal to x equals to negative 3.98869. Okay. Now, this is what we call approximate form. Now, when you do approximate form, I need you to give me 5 decimal places. But don't do any rounding until you are done with your computation, and then you round it to 5 decimal places. Okay. Every time you do computation, not only in my class, in other classes too, do not round your calculator answer, your approximate answer. Don't round it until you're done with your computation. Okay. That's to avoid compounding rounding error. Now, again, this is what we call exact form. This is the exact form here. That's the notation before you start using calculator. And this is what we call approximate form, basically the decimal. Now, when you write it in decimal, give me 5 decimal places. Okay. Now that's for number 14 and the variation. Now we go on further. Suppose, for example, I look at number 16. Number 16 is the type of question I usually ask in my test. So you may want to put a star here. Make sure you study this type of question. Okay. Now, number 16, we have 4 to the power of 2x plus 3 equals to 5 to the x minus 2. There are 4 different ways to do this. Depends on, and there's none of these 4 different ways is something I favor. No. In fact, maybe I say this way, you have these choices. You see that we have base 4, we have base 5, right? So we can, the first 2 methods, basically either you work on base 4 or you work on that on base 5. Now, I think our textbook or some other instructors correctly says that you may prefer to deal with base 10 or even base E. Now, those are 4 different ways you can work on the problem. Now, I don't think we can do it another way because 4 and 5 are not bases to each other. Okay. Now, let me show you 2 of them. Let's say I use base 4 first, and then later on I show you how to do base 10, for example. Okay. Let me start with if I do that in base 4. How to do that in base 4, then I will see in the following way. I will see this 4 as my base, take this 2x plus 3 as my exponent, and this 5 to the x plus 2 is my argument later on. Okay, so when I change it into base 4, this will be log base 4 of the argument 5 to the x minus 2 equals to the exponent. I know this is quite colorful. I hope it doesn't distract you, but you can see what I'm actually doing. Okay, I change it into log form. Now then, from that log form, I try to solve for x. Now I will use property number 3, in which this exponent x minus 2, I bring it to the front. So x minus 2 times log base 4 of 5 equals to 2x plus 3. Now, I hope you are following me in writing. Now, our purpose is to solve for x, right? Now, I have x here. I also have x here. Now, then what I think I will do is I will distribute the left-hand side first, and then collect the x term on one side. This is x log base 4 of 5 minus 2 log base 4 of 5 equals to 2x plus 3. Okay, now I will move the x term to the left and the constant term to the right. Now, even though this guy here looks so ugly, 2 log base 4 of 5, but that's actually a constant. Okay, I just don't use my calculator yet, because if I do calculator too early, I may have a rounding error, and I want to find the exact solution first. Okay, so I will just keep it that way, knowing that it will be a constant. Okay, now then going back on the left-hand side, therefore I will have x log base 4 of 5 minus 2x equals to 3 plus 2 log base 4 of 5. Now you see that the x term now together, right? Now guess what? What do we do next? That's right, we factor the x. So that will be x log base 4 of 5 minus 2 equals to 3 plus 2 log base 4 of 5. And then the x will be the exact form. It's 3 plus 2 log base 4 of 5 over log base 4 of 5 minus 2. Now, that's the exact form. Okay, now I continue further to find the approximate form. To find the approximate form, then it will look like this. Let me rewrite it first. I do the change of base first. This will be 3 plus 2 times log 5 over log 10. I'm sorry, log 4 over log 5 over log 4 minus 2. By the way, you still can call this an exact form because I don't do any decimal yet. Okay, yeah. If then from here, if you want to use calculator, go ahead. But if I were you, I will simplify that a little bit. I will multiply by log 4, log base 10 of 4, and to get next stage, 3 log 4 plus 2 log 5 over log 5 minus 2 log 4. Okay, now this form is actually the one you can use calculator with if your calculator has only base 10 and base E. Okay, now let me show you how to punch this into our calculator. You can try that too. You try that too, okay? You try that too. So this will be, let's see, that is 3 log 4, 3 log, I'm sorry. You know what? I need to use parentheses first because later on I will divide this whole chunk on the top by something on the denominator. 3 log 4 plus 2 log 5. Close the parentheses plus 2 log 5. Don't forget to close the parentheses. Okay. Now, the last parenthesis I close is for the log 5. Now, I will close that again for the whole chunk on the numerator. Let's go back to our notes. So what I just type it, I just type deal with the numerator here. Okay. Now, I use parentheses on the top and close it before I go to the bottom. Now, when I go to the bottom, I need to use parentheses also. Okay, because it's a group of the numerator divided by the group of the denominator. Okay, so go back to our calculator. That's divided by open parentheses. Now we start with the chunk on the denominator. Log 5 minus 2 log 4. Log 5, close that 5, minus 2 log 4. Close that 4, then close that denominator. Okay, I get negative 6.34291. That's equal to negative 6.34291. Okay, now let me make sure that you have time to use your calculator and confirm your answer. I'll give you 1 minute to punch this in case you have not done this. Okay, because I need you to know how to use your calculator. Okay, I need you to know how to use your calculator. Let me give you 1 minute to try that. Oh, you know what? On the top of that 1 minute, let me ask you to also try number 18. Number 18. Number 18, 3 to the 2 minus 3x equals to 4 to the 2x plus 1. I will show you how to do base 10 later on if we do it in base 10. But for now, you can choose. After you're done with the number 16, how to find the approximate form, I want you to do number 18 in exact form and then in approximate form. I think for number 18, you may want to use base 3. You can also use base 4, either one. Okay, let's do that in 5 minutes. In 5 minutes. So first, I want you to do this one here. Okay, number 16, and then number 18. Okay. I hope you are done with that number 16 and also with number 18. At least get some good feeling about that number number 18. Let's see again. Number 16. The answer should be negative 6.34291 if we round to 5 decimal places. Okay, but in my test, I always want you to write the exact form first and then the approximate form. Approximate form. Okay, now let's see what happened with number 18. Suppose I use base 3. So log base 3 of 4 to the 2x plus 1 equals to 2 minus 3x. And then using property number 3, I have 2x plus 1 times log base 3 of 4 equals to 2 minus 3x. Then I distribute this. to the constant, right? Okay, I will distribute to the constant log base 3 of 4. Then I have 2x log base 3 of 4 plus log base 3 of 4 equals to 2 minus 3x. Now I have this x here, I have this x here, I will put them together, you know, on the same side. So I have 2x log base 3 of 4 plus 3x equals to 2 minus log base 3 of 4. Okay, now then I will go on, factor this x here on the left hand side. I get x times 2 log base 3 of 4 plus 3 equals to 2 minus log base 3 of 4. Okay, therefore x is equal to 2 minus log base 3 of 4 over 2 log base 3 of 4 plus 3. Okay, now let me rewrite that with change of base. This is 2 minus log 4 over log 3 over 2 times log 4 over log 3 plus 3. Now, if you have calculator like our friend that can do any base, then you don't need to do this step. But if I anticipate the fact that one day later on you don't use the same calculator, so like the calculator we have on our computer only have base 10 and base E, you know. Okay, so without calculator, if you have to use computer, then you need to anticipate that situation. I will multiply the LCD log 3. So now my x equals to, this is still in exact form, by the way. My x will be 2 log 3 minus log 4 over 2 log 4 plus 3 log 3. Okay, now then that's the end of the exact form. So we can say the following are exact form. This is exact form, this is exact form, this is exact form. Because we don't use calculator yet, okay? And they are still in exact form. I mean, no approximation yet, okay? But of course, this is the first time you get the exact form. This is the one right before you use calculator. Now, if I use calculator, let's see. Then that will be parentheses for the group on the numerator, right? 2 log 4, I'm sorry, 2 log 3, 2 log 3, close parentheses, minus log 4, close parenthesis, close another parenthesis for the numerator. Now divide it by the group of the denominator. That's why I start with divided by that parenthesis. Okay, the parenthesis, the group of the denominator, 2 log 4, close parenthesis, plus 3 log 3, close parenthesis for the 3, and close parenthesis for the denominator. Enter. That's 0.13363. 0.13363. That's 0.13363. 13363. Okay. Now the question is, Thomas, what happened if we use base 10? Let's see if I do that number 14 again. You know what? I do number 18, number 16 or 18. I do number 18. Number 18, but this time using base 10. So what happened is I start with 3 to the 2 minus 3x equals to 4 to the 2x plus 1. Okay, now because logarithmic function is a one-to-one function, I will apply log to both sides. In this case, I will apply log base 10 to both sides. I apply log base 10 to both sides. And then from there, I apply property number 3. So I get 2 minus 3x times log 3 equals to 2x plus 1 times log 4. Okay, next I will distribute because this guy here, and this guy here, log 3 and log 4, are basically constants. Okay, they are basically constants. If I try to use calculator too early, then I have the decimal too early, and that decimal will be approximation already. Okay, so I will just leave them like that. Okay, we know they are constants. I will distribute that constant, so I get 2 log 3 minus 3x log 3 equals to 2x log 4 plus log 4. Now notice that we have x term here, we also have x term here, right? Let's move, I think I will move, because this is negative coefficient, let me move this guy. I will move this guy to the right instead. I will move this guy here, move it to the right, so it becomes plus. Which means I will move the constant on the right hand side to the left. Okay, so I will have 2 log 3 minus log 4 equals to 2x log 4 plus 3x log 3. Now take a look first. So basically, this time I have my x term on the right hand side. Okay, now once the x terms on one side, then I can, in this case, I can factor it, right? So I have 2 log 3 minus log 4 equals to x times, I factor the x, 2 log 4 plus 3 log 3. Okay, now finally, my x will be my x will be 2 log 3 minus log 4 over 2 log 4 plus 3 log 3. Now, this is what happened if I execute this using base 10. Okay, but this is our exact form. Which if we look back to the way we did it earlier, using base 3, or even if we use base 4, we actually have that answer. We have this answer here. We have this answer here somewhere earlier. Here. Notice that these are the same expression. What we have up there and what we have down here, they're actually the same, right? Now the reason is because originally when we did it first time, that number 18, when we did it first time, we did it in base 3, and once we get the exact form, when we try to transition into approximate form, I need to do change of base. Okay, so when I do it change of base, that's what it looks like, right? Now, it turns out that when I did the change of base into base 10, which for Regan's calculator is not necessary, okay? But for other people, when you need to change the base to base 10, for example, that's the answer you have if you do base 10 since the very beginning. Okay, so expectedly, when you use calculator later on, you have the same answer here. This x will be, this x is equal to 0. What's that? 13363. 13363. Okay. So through this example, the last example we have here, number 18, I show you two different ways. The first way that we did, I did log base 3. I work on base 3 mode. You can also do in base 4. You will get the same answer. You'll get the same answer. Okay, if you do in base 4. If you do in base 10, you will get this in the exact form, and you will get the same answer. In fact, I can tell you something. Suppose you do in base E. Suppose you work the problem in base E. Your answer later on will be 2 natural log 3 minus natural log 4 over 2 natural log 4 plus 3 natural log 3. In which I basically change all the log, base 10 into natural log, which is base E. Okay? Yeah, that's only for 10 and E. Anyway, you can try it yourself when you have a chance. Of course, between now and Wednesday, I want you to focus on your test too. Okay? Going back here, I think I want to emphasize again, this is one type of question that I always ask in my intermediate algebra class and my Precalculus class, always. Okay, so make sure you study this type of question during your when you do your homework, suggested homework, and before the test. Okay, now let me go on. Still on exponential equation. Let's take a look on number 26. Number 26, we have 3 times 3 to the x plus 9 times 3 to the negative x plus equals to 28. Okay, you can see this problem as written this way: 3 times 3 to the x plus 9 over 3 to the x equals to 28. You can see it that way. Okay, and then you realize, oh, you know what? I can substitute this ugly guy here by u, and I can multiply that by the whole equation by u. Okay, so suppose I multiply by 3 to the x, I will get 3 times 3 to the x squared plus 9 equals to 28 times 3 to the x. And then I will let u be our 3 to the x. You see what I mean? So I get 3u squared plus 9 equals to 28u. Then we solve that by as a quadratic-like equation, basically. Okay, some words of warning. When you write your exponent, make sure that your exponent is a superscript. I have seen so many people did a super silly mistake. They overlook the need of writing the exponent properly. They write it this way, and guess what? They will see this as 3 times x, which is not what we want to write. But because you don't write it right and you don't pay attention to details, you make that mistakes. And the mistake actually not because Thomas not being clear. No, that's because you yourself didn't write it right. Okay, so please be attentive to your own handwriting. Okay, now that's 3 to the x. So the x there, the exponent here, has to be written as a superscript. Now that's the plan. Okay, so going back to our original question here, you can see, oh, you know what? This is actually 3 to the x on the denominator, right? Okay, that's 3 to the x on the denominator. Let me multiply by 3 to the x. I multiply by 3 to the x. Now it becomes 3 times 3 to the x squared plus 3 to the negative x times 3 to the x. As you can see here, when you multiply by 3 to the x, it becomes 9, right? And the last term on the other side of equal sign, we get 28 times 3 to the x. Now, when I let u equals to 3 to the x, I get the equation now becomes 3u squared plus 9 equals to 28u. Okay, the one on the red color here, just to help you mimic what actually happened. Okay, but you can write it in red, the one on the red, on the right hand side here. You can write it using this style here. Okay, or you can use the one on the left also. Either way, it's fine. Okay, just show your step in between. Now notice that either you do on the left hand side or the right hand side, you get the same equations, right? Okay, so let me just continue. It's the same to the way I will do that anyway. Okay, notice that it becomes a quadratic equation. Okay, now then from here we solve that as quadratic equation. If it is factorable, then you have to factor. Okay, I want you to do it that way. If it is factorable, you have to factor. Then this is minus 9 here, and this is minus 1. So u equals to 1/3, or u equals to 9. Now this is 3 to the x equals to 3 to the negative 1. Therefore, x equals to negative 1. Or 3 to the x equals to 9, which is 3 squared, or x equals to 2. Okay, those are the answers. Okay, but the basic idea is from this original equation here, you identify that if I multiply by 3 to the x, I get something, an equation that is quadratic-like. Once it is quadratic-like, that's something we learned way in chapter 2, as I remember. If not chapter 1, that's chapter 2. That I will substitute to help us simplify the loop of the equation. Okay, and then we solve that whatever method we can. in solving quadratic equation. Okay, with one warning though. In this case, because it's factorable, I need you to solve that by factor. Now, number 28, however, is not factorable. Let me ask you to do number 28 to the point that it's quadratic equation. So 2 to the x times 6 times 2 to the negative x equals to 6. Okay, let me ask you to work it out. Okay, or maybe I just do it quickly. Okay, I multiply by 2 to the x, I get 2 to the x squared minus 6 equals to 6 times 2 to the x. And then I let u equals to 2 to the x, such that my equation now becomes u squared minus 6 equals to 6u. Notice that this is now a quadratic equation. However, I don't think that's factorable. Then how to solve that, Thomas, if it is not factorable? Well, we have other method, completing the square or formula. I think this one here, because the leading coefficient is 1 and the coefficient of u is even, I think I will use completing the square. Okay, so u squared minus 6u equals to 6. What number do I add to both sides to complete the square? That's right. I will add 9 to both sides. Okay, then we get u minus 3 squared equals to 15. So u minus 3 equals to plus minus square root of 15. Is it okay? And then u equals to 3 plus minus square root of 15. Now change it back to 2 to the x. 2 to the x equals to 3 plus minus square root of 15. So x is equal to log base 2 of 3 plus minus square root of 15. Okay, but we are not done yet. Something not really right there. Until you split it, you will not see it. Okay, x1 equals to log base 2 of 3 plus radical 15. And the second solution, that's x equals to log base 2 of 3 minus radical 15. Now, unfortunately, 3 minus radical 15, is negative number. Now, 15 is between 9 and 16, right? Okay, so square root of 15 will be between square root of 9, which is 3, and square root of 16, which is 4. I don't need calculator to actually find out what that. You just see that, you know. Okay, so square root of 15 is greater than 3, which means 3 minus square root of 15 is negative. Okay, but for the log, the argument for the log cannot be negative. Remember? Okay, that's not right. Okay, so I have to cross that answer. Okay, because 3 minus square root of 15 is negative. That's not in the domain of log function. Okay, so the only solution is this guy here. Okay, that's the only solution. But Thomas, why in this question we have one solution and the previous one we have two solutions? Well, honestly, we don't know. We never know. We never know. Okay, we never know. you have to work it out all the way and then check. Okay, just like this one here. Suppose out of just for fun, suppose let's say I have u equals to -2. Okay, just for to simplify that. Now, 3 to the x equals to -2, then x equals to log base 3 of -2. But that's impossible. Okay, so in that situation, from this branch, there's no solution. Okay, so we will not know until you actually work it out. Okay, we never know. So it is just by coincidence that this question earlier, number 26, has two solutions, and the last question we did, number 28, has only one solution. Trust me, it is possible that we have no solution at all. It's possible. Okay, now that's for number 28. Let me ask you to try number 27. Oh, actually, I'm not done yet. The answer we have here is in exact form. What will that be in approximate form? This is exact form here. Okay, and what will that be in approximate form? Let me ask you to use your calculator. You do your calculator and I do my calculator. And by the way, this part here, you actually don't need to show. I just show you how we visually check, hey, you know what, something wrong with the domain, or something wrong with the argument there, such that I have to cancel that one answer. Okay, log base 2 of 3 plus radical 15. If I try to compute that using calculator, and my calculator has only base 10 or base e, let me make it to base e right now. This is natural log of 3 plus radical 15 over natural log of 2. If you use base 10, basically change this natural log into log base 10. Okay, but in the end, we will have the same answer. Two 2.78094. 2.78094. Okay. Anyway, we are pretty much done with the exponential equation. We're pretty much done with exponential equation. Of course, you may see some kind of a little bit tricky questions. I will show you one very, very soon. Okay, but this is the outline of exponential equations. That's what we have so far from the very beginning. Okay, exponential equation all the way up to here. Now, the following are the type of question that requires you to be a bit creative in solving problems. Let's say if I have, give me a second. Let's say if I have, let's say I have 3 to the x plus 1 minus 3 to the x equals to 54. We have common base 3, but 54 is not base 3. So that's not what we are going to. The things that we need to be aware of is this guy here. 3 to the x plus 1 can be rewritten as 3 to the 1 times 3 to the x. Okay? Which then, if I factor 3 to the x, if I factor 3 to the x, I'll get 3 minus 1, right? Or if you want, you can change that. Let u equals to 3 to the x. Then you will see 3u minus u equals to 54. So 2u equals to 54, right? This is 2 times 3 to the x equals to 54. Okay, notice that these two are equivalent. Okay, so u equals to 27, and then I put that u back. This is 3 to the x equals to 27, blah, 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 x equals to 3. Okay. Divide by 2 both sides, and I rewrite that 27 as 3 cubed, so I get x equals to 3. Okay, but this type of question requires you to know some properties for exponential properties for exponents. Now, let me summarize what we have so far. What we have so far is this. Basically, note if have common base, if we have common base, either base 10, base E, base 3, base 4, okay, then you can use that. Otherwise, choose any base. Okay, base E, base 10, base 3, base 4, whatever you think convenient. Okay, now second, okay, now when we to solve a to the x equals to b, now depends if b can be written as the common base, the base a. If not, then we use log. Okay, either we change b into base a, or you write log base a of b equals to x, like that. Okay, so we have that options. Now, how about when we have logarithmic equations? I believe I have said that before, explained that before. What do we do if we have logarithmic equation? You will see mainly our work end up with, we try to get these two forms. What forms? We try to have log base a of blah equals to log base a of blah. If we have log blah equals log blah, it implies blah equals to blah. Okay, with a note that blah and blah has to be strictly positive. So once you get your final answer, you need to check the argument has to be positive. It cannot even be 0. Okay? Now, so the first form is you have log equals log. The second form, if you have log equals constant, log base A of blah equals to a constant, let me call that constant a triangle. Now, if you have log equals to no log, then we change it into exponential form. A to the exponent equals to the argument. And then from there we solve further. Okay, now that's the plan for log equation. That's the plan for log equation. Now, of course, in between then, we will apply these properties and that property. Let's say, for example, we do number 20. Let's say, for example, we do number 20, log of 5x plus 1. What is the base here? If you don't see any base on the log, that must be log base. That's right, that's base 10. Okay, now notice that we have log in this term, we have log in this term, but we have constant here. Now, so my plan is I will move the log part to one side. Okay, so I only have the log part on one side and then the constant part on the other side. That's my plan. Okay, so the constant part 2 on the right hand side and then the log part on the other side, log of 5x plus 1 minus log of 2x minus 3. On the left hand side, I have difference of logs. Now try to make it into single log. So apparently we will go into this style here. So at the end, on the left hand side we have log, on the right hand side already constant. Okay, now on the left hand side, log blah minus log blah, that's property number 2. So log minus log is log of quotient. Okay. Now I already have single log on one side and constant without log on the other side. Now, guess what? What do we do after this? Change it into exponential form. Okay. Now, Thomas, how do we know that's base 10? Well, because log without any base implies log base 10. Okay, if we don't write any base, we don't write the base under the log, then that's base 10. Okay, keep that in mind. Now from here we solve it as usual. This will then be, let me continue that side. So this is 5x plus 1 over 2x minus 3 equals to 100. So 5x plus 1 equals to 100 times 2x minus 3. That's 5x plus 1 equals to 200x minus 300. We pull the x together, so 300 plus 1 equals to 200x minus 5x. That's 301 equals 195x. So x is equal to 301 over 195. Okay, now when we solve log equation, make sure that you have one last step that you need to check. You need to check that the argument for that x will always be positive. Okay, the argument for when I plug in x here, the x into the argument, it has to be positive. Okay, you can just visually check that. You don't need to show the check like when we do radical equations. Radical equation with even index, you have to show the checking formally. Okay, but for log, no, you can just visually see that when you plug that in, if it turns out to be negative in the argument, then you cross it out. Okay, but I believe this one here, it will be positive because this is approximately 1.5, more than 1.5, right? More than 1.5. When I plug in here, more than 3 minus 3, that will still be positive. This guy, x is positive, so the whole thing is positive. Okay, so that's the answer. Okay, now let me go on. That's for number 20. Let me go on to number 22. Number 22, you know what? You can try to do this problem though. You can try to do this problem. Log of x plus 3 plus log of x minus 3 equals to log of x squared plus 5 minus 2. I think you will put these logs all together on the same side. Okay, and then after that, you put them into a single log. Okay, because it is base 10, then whatever you have here equals to 10 to the negative 2. And then from there we solve further. Okay, let me ask you to do that. Together with your break. Break, we come back at 11 o'clock. I will put them together. Let me execute the plan I told you earlier. So that's log x plus 3 plus log x minus 3 minus log x squared plus 5 equals to negative 2. And then if I put them together, the numerator will be x squared minus 9. The denominator will be x squared plus 5. So x squared minus 9 over x squared plus 5 equals to 10 to the negative 2. Now, I do not recommend you to make it into decimal there, but let's rewrite them into fractions. So x squared minus 9 over x squared plus 5 equals to 1 over 10 squared, which is 100. Okay, cross multiply, I get 100 times x squared minus 9 equals to x squared plus 5. So 100x squared minus 900 equals to x squared plus 5. Subtract by x squared both sides, that's 99x squared, plus 900 both sides, that's 905. So x squared equals to 905 over 99. And then when I do the square root, I get plus minus square root of 905 over 99. Split them. We need to split them. So x equals to square root of 905 over 99. That's x1. Our x2 will be negative square root of 905 over 99. Okay, but this is negative, which if I plug in here, when I plug in here, especially this one, when I plug in there, this part here will be negative, right? In the original equation, actually. And in the original equation, when I plug that in here, it will be negative. You see? Okay, so I have to reject this solution here. It's not applied. And when I check x1, I think x1 will be fine. There will be more than 3. This guy is, I mean, if I do it visually, this guy is greater than square root of 905 over square root of 100, right? Is it right? Okay, but this guy is square root of 9.05, which is greater than 3. Okay, now greater than 3 minus 3 will still be positive. So that will be fine. Now, of course, if you are not sure, Thomas, I cannot really do that approximation, which I expect you to be able to do it at this level. But if you cannot, then just use your calculator. Okay? If you cannot use your calculator. Let me continue. If I simplify this, I can take the 9 out. So that will be 1 over 3 square root of 905 over 11. That's 1 over 3 times 11 square root of 905 times 11. That's to rationalize the denominator. Okay, that's to rationalize the denominator. I think our textbook solution, yeah, our textbook write the answer only like this, and then they use calculator. Okay, but if in my class, of course, I need you to rationalize the denominator. Okay, so your final answer is supposed to be square root of 9,955 over 33. Okay, I'm not sure if I can simplify this though. 905. It's 181. No, it's not. Yeah, I think that will be your final answer if you don't use calculator. And this is actually what I want to do. Okay, but to be honest with you, I will be happy enough if you can give me your answer in this yellow color here. Okay, make sure you cancel this one though. Okay, make sure you cancel this one because this is not in the domain of a log function. Okay, that's for number 22. Let's do one more problem in which all logs. Let's say, for example, I ask you to do number 24. I want you to do this though. Okay, number 24, log of x minus 4 minus log of 3x minus 10 equals to log of 1 over x. Now, I want you to do this, but I give you the plan. What's the plan? The plan is you will combine this into a single log. This is log something. Okay, now then because log blah equals log blah, then whatever you have here becomes blah equals blah. And from there you solve it further. Now once you're done, you need to check against the domain of the equation. Okay, let me give you, let's say, 5 minutes to do this. I think the answer will not be a nice, well, it could be a nice number. I don't know. Okay, but try to work it out. I'll give you 5 minutes from here. Okay, let's see what you have. You may not done yet, but that's okay. At least you have some feeling on this. This will become, we need to make it into single word. So it's x minus 4 over 3x minus 10, right? Okay, and then log blah equals log blah. They have the same base. So now that means we have x minus 4 over 3x minus 10 equals to 1 over x. Now I will cross multiply. I get x times x minus 4 equals to 3x minus 10, x squared minus 4x. Let me move it to the left at the same time. Minus 3x minus plus 10 equals to 0. So x squared minus 7x plus 10 equals 0. Fast forward, that will be x equals 2, x equals to 2, and x equals to 5. I think 2 will not work, right? Because when I plug 2 here and also here, it will give us negative value, right? So I will cancel that. Will 5 work? Yeah, I think 5 will work. It will be positive here, it will be positive here, that will still be positive here. Okay, so the answer is x equals to 5. Now, we are basically done with this section here, except that I would like to go on to the next page, page 314, to see a more advanced questions. The type of questions that we have done so far in this last 1 hour something, should I say 2 hours? Yeah, 1 hour something, is actually the type of question I would ask even in lower level class in intermediate algebra. Okay, but I still ask them anyway because you need to know those basics. Okay. Now, the type of question you need to, you expect to see are this type. Number 30, for example, log of square root of x equals to square root of log x. Okay, now, how to do this one? Now, notice that on the right-hand side here, I can write this as log x to the power of 1/2, right? While on the left-hand side, this is log of x to the power of 1/2. Now, you know these two are different. They are not the same. On the one on the left-hand side, we can use property number 3. That's 1/2 log x equals log x to the power of 1/2. Okay, now to better see this problem, I suggest us to use some substitution. Let u equals log x. Okay, so then our equation becomes 1/2 u equals to u to the power of 1/2. Now then we basically have a square root equation, right? Square root equation now. Another way to see this is u over 2 equals to square root of u, right? If you think about it. Now I will square both sides. I get u squared over 4 equals to u. U squared equals to 4u multiplied by 4 both sides. Okay, so u squared minus 4u equals 0. U times u minus 4 equals 0. So either u equals to 0 or u equals to 4. Okay, now then I bring it back to the log. This u is log x, right? So log x equals 0 or log x equals to 4. Now if log x equals to 0, then x equals to 10 to the 0. Remember, I change it back to exponent. 10 to the 0 is 1. But you need to make sure that later on, you need to check against the original equation. Okay? Yeah, but I think that we are okay with that. And then the second branch, x equals to 10 to the 4, which is 10,000. Okay, and they are both okay. That's for number 30. Any question?
Professor, can I look at the question that the previous one?
Oh, okay, sure.
Thank you. I just didn't finish covering it.
Okay.
Thank you.
And that's for number 30. Number 32 is actually quite simple. I don't even think I want to do that, but I give you the idea. You know, number 32. Just remember, every time you deal with log equation, especially log equation, you need to check against the domain of the equation. Okay? Yeah, log of square root of x squared minus 9 equals to 2. Now, this question, even though it looks complicated, it's actually on the easy side. This is base 10, log blah equals constant. So I change it into exponential form, square root of x squared minus 9 equals to 10 squared.
It's x cubed minus 9.
X
And on the
cubed.
problem.
Oh, thank you. Okay, yeah, okay, thank you. So this is x cubed. Right, and then I change it into exponential form. I square both sides, so x cubed minus 9 equals to, this is 100. When I square it, that becomes 10,000, right? Now then I add 9, do cube root. So x equals to cube root of 10,009. I can always skip little steps here and there. Okay, now then you see that x cubed minus 9 here is a positive number, right? The guy that we have in here is this, which is a positive number. So we are fine with that solution. Okay, number 34 is actually similar to question number 30. That's log of x cubed equals to log x being cubed. Now, the one on the right-hand side stays the same. The one on the left-hand side, I bring the 3 here to the front. So that's 3 log x. And you know how to do it from here. You say let u equals to log x. You see what I mean? So we get 3u equals to u cubed. And from here, we solve by factoring. I think this is doable by factoring. I factor u, and then I have u squared minus 3. So either u equals to 0 or u squared minus 3 equals 0. You can do it from this branch. This one here, u squared equals to 3. So u equals to plus minus radical 3, which you're supposed to split later on, right? So u equals to radical 3, u equals to negative radical 3, and then you bring it back. Okay, so you solve it here. This is log x equals to radical 3, so x equals to 10 to the radical 3. Okay, and the one here you will get x equals to 10 to the negative radical 3. Okay, now that's the skeleton of the question. Now, the type of textbook we use at West LA College, in my opinion, is preparing us for Precalculus better than this textbook. I mean, this textbook, the book that we use here, has its own benefit. The textbook we use there has its own benefit. But you may see a question like this in future. The following question: two log x equals to log x squared, for example. How do we solve this? How do we solve this? Now, notice that you may think correctly think that both left and right hand side are actually equal, because by property number three, we have that log base b of x to the n equals to n times log base b of x, right? So the left-hand side are the same to the right-hand side, so right? Not really true, because right before this property number three, okay, there's a requirement saying that the argument has to be positive, okay? If you remember the statement, the full statement is actually as the following. Let me erase that first. Yeah, the full statement is actually the following. For m n positive, okay, log base b of m to the n equals to, actually doesn't have to be, this one doesn't have to be positive, to the x equals to x log base b of n. Okay, so even though this equation here seems to be an identity, what we need to take care is that the argument has to be positive. Okay, the argument has to be positive. Now, so how do we going back to this question, how do we solve this? Then we say that this is 2 log x equals to 2 log x. That's basically identity, right? So the solution supposed to be originally, all real numbers, okay? However, when we look back to the original equation, we see that x has to be strictly positive. Okay, the argument has to be strictly positive. Now, this guy here cannot be zero. Strictly positive for the x, and x squared cannot be zero. Basically, still strictly positive. So, if I do quote unquote the intersection between, so if I do the intersection between all real numbers with the set of all x that's positive, right? If you take a look on the number line, all real numbers refers to the whole thing here, okay? But greater than zero refers to this thing here. You see what I mean? Okay, so the solution will be only from 0 to infinity. Okay, I try to pick an easy question, like so that we can focus on the real problem of this question. The real problem is, it seems to be quite innocent that they are identity, but we actually need to make sure that whatever the solution we have is in the domain of the equation. Okay, that's things that you need to be aware of. Now, let me go on further. One more question that in the past I consider this to be actually quite standard, but I then have plenty of students asking me how to do it in my office hours. So instead of waiting for you asking me this question, let me do, for example, number 42. Number 42, solve for x. Y equals to 10 to the x plus 10 to the negative x over 10 to the x minus 10 to the negative x. Okay. Let me rewrite this first so that we have a better visualization. This will be, the top left is 10 to the x. The top right is 1 over 10 to the x. Bottom left, 10 to the x. Bottom right is 1 over 10 to the x. See, that's what it looks like. Okay, at this point, if you want to do substitution, go ahead. But I will postpone it until slightly later. Okay, I will multiply by 10 to the x on the top and the bottom, so that I don't have complex fractions. Okay, so if I multiply by 10 to the x, I get on the top left 10 to the x squared minus plus 1 over 10 to the x squared minus 1. Okay, now then from here you can do substitution. You can say let u equals to 10 to the x. Okay, or in fact you can also say that this is you can also use, on the other hand, another option is let's say w equals to 10 to the x squared, because they happen to be 10 to the x squared there for both this guy here and this guy here. Okay, so you have two options to look at the problem. Okay, now suppose u is 10 to the x, then y equals to u squared plus 1 over u squared minus 1. Now we will solve for u. Okay, and then once we get the u, whatever that is, that's 10 to the x, right? So x will be log of whatever you have here. Okay, let me try to execute it so that we don't get too vague. Okay, so this will be y times u squared minus 1 equals to u squared plus 1. Y u squared minus y equals to u squared plus 1. So y u squared minus u squared equals to y plus 1. I will factor the u squared. I factor the u squared. Y minus 1 here. So u squared equals to y plus 1 over y minus 1. So u equals to plus minus square root of y plus 1 over y minus 1. Hold on. So u1 is the positive branch, and u2 is the negative branch, right? When I replace that, that's 10 to the x for the u. Notice that 10 to the x is an exponential function whose range has to be a positive. So you will see once we rewrite it here, we see that the right-hand side cannot happen, right? This cannot happen. This cannot happen. Okay. You can try one step further. If I go one step further, then I will get x equals to log base 10 of a negative number, right? Okay, but log cannot have a negative argument. You see, so there's no solution from that branch. On the first option, on the other hand, we can go further. This is x equals to log of square root of y plus 1 over y minus 1. Okay, which we can go on a bit further. We can go on a bit further, saying that this is x equals to 1/2. You see the square root means exponent of 1/2, right? Log of y plus 1 over y minus 1. Okay. Yeah, so the idea is actually quite simple. It's just like too many basic ideas put together that you don't expect. We have so many things that get complicated here. So the first thing is like I need to rationalize. I need to simplify the complex fractions here. I need to simplify the complex fraction here. Okay, so once it gets simplified, I do substitution and solve it from there. Okay, solve it from there. Thomas, what happens if I do the red color there? You can. So if you think about this, W is actually 10 to the 2x now, right? You can rewrite this as a 10 to the 2x. You can rewrite this as 10 to the 2x, 10 to the 2x, right? Okay. And if you go on, you will actually get this answer here directly, to be more precise. Okay. Yeah, you can try to do that branch. Now, suggested homework from this section. Of course, I don't expect you to do that during between today and Wednesday, but I would like you to do this between Wednesday and Monday. Suggested homework from 4.6, that will be from number 1 to number 45. I know it seems to be a lot, but the first couple questions, actually the first 10 questions are on the easy side. So half of the question is on the easy side, and the other half maybe medium size. Nothing, I don't see hard questions here yet. Okay, just do the odd ones from this 4.6. Now, let me go on to 5.1. 5.1 is actually a section you can just read, but there are things I want to emphasize. 5.1, that's on angles. Okay. What is an angle? My assumption is you come to this class with some background in geometry. So you know what is an angle. An angle is the opening formed by two rays with common initial points. Okay, so let's say the common initial point here is O, and one ray is rho OA, the other ray is ray OB. Now this angle is called angle AOB, or we can also call this angle BOA. Now, in geometry, we call these two angles, they are congruent because they are reflective. Okay, basically the vertex, if you write it using 3 letters, then the vertex is written in the middle. That's the vertex. Okay, now of course we can also call this angle O, even though sometimes sometimes we use Greek letter theta, or alpha, or beta, lowercase Greek letter. Okay, now that's for angle. Now, then some definition, coterminal angle is the angle with everything common. Common vertex, okay, common initial side, and common terminal side. Let's say, for example, I grab these angles here. Oh, sorry. Now, what do we mean by coterminal angle? Now, let's say this is angle alpha. Let's say this is angle alpha. Notice angle alpha has initial side OA, vertex O, terminal side OB. Now, this angle alpha here is coterminal with angle beta if we go this way. Now, the red angle, let me call that angle beta. Red angle is clearly more than 360 degrees, right? Okay, but the opening of this beta is called coterminal angle because it starts from the same initial point, initial side. It shares the same vertex and the same terminal side. In fact, we can go backward. Let's say this is my initial side with vertex O. I go this way. So the same initial side, the same vertex, the same terminal side. Let me call this angle gamma. Then alpha, beta, gamma, angle alpha, angle beta, and angle gamma are coterminal. Okay, because they share the same vertex, initial side, and then terminal side. That's for the term coterminal angle. Next, angle in standard position. Angle in standard position is as the following. Suppose I have rectangular coordinate system. Okay. Now, an angle is in standard position if it starts from the positive x-axis with vertex at origin, and the angle is going in counterclockwise. Okay, so we say the angle is in standard position. The angle is in standard position if first initial side is positive x-axis. The vertex is origin, 0, 0. And the angle is the terminal side. The angle is moving counterclockwise. The angle is measured counterclockwise. Okay, now in trigonometry, unless otherwise mentioned, unless otherwise said, then the angle will be given in standard position. So if nothing else said, and I say, oh, angle 30 degree. Now, when you say, somebody say angle 30 degree, there's no need for us to say, oh, you know, is it from x-axis or y-axis, positive x-axis or negative y-axis? You know, is it clockwise or counterclockwise? Where's the vertex? No need, okay? No need, because we now have a convention that unless others otherwise said, then the angle must be in standard position, which means the initial side is positive x-axis. Okay, the vertex is origin, and the direction of the angle is counterclockwise. Okay, so when we say, for example, 90 degree, when we say 90 degree in, oops, sorry. When we say 90 degree in trigonometry, it refers to right away, 90 degree refers to this angle here. (90°) because it's 90 degree from the positive x-axis. Okay, this is the angle alpha equals to 90 degree. We don't need to say further that it is measured from positive x-axis with vertex origin going counterclockwise. No need, no need. Okay, once they say 90 degree, that's what it means. Okay? There's no confusion there. Okay, now that's for angle in standard position. Now we can see further that angles are coterminal if they differ by 360 degrees. For example, if the theta here, let's say the theta here is 40 degrees, for example, then if I add 360 degrees, if I add 360 degrees, okay, so they are coterminal. Okay, so 40 degrees is coterminal, and we use this notation, coterminal to angle 400 degrees. If you want to go further, that's still coterminal to, suppose if I add 360 degrees to that 400, I get 760 degrees. They are still coterminal. In fact, if I subtract by 360 degrees, that's negative 320 degrees, they are still coterminal. Okay, all of these are coterminal. Why? Because they have the same initial side, common vertex, and common terminal sides. Okay, that's a little review on our word coterminal. Now, some further definition. the type of angles. An angle that is less than 90 degrees is called acute angle. So, an angle that is less than 90 degrees is called acute angles, because it is less than 90 degrees. Visually, you see that it is in quadrant 1 if you put it in standard position. Okay, an angle is called obtuse angle if it's between 90 to 180 degrees. Okay, this is obtuse. This is acute. Okay, so an acute angle it means the theta is between 0 degrees to 90 degrees. For obtuse angle, means the theta is between 90 degrees, greater than 90 but less than 180 degrees. Okay, now of course then I hope you remember what do we call if the angle is 90 degrees. Exactly 90 degrees. We call that right angle. What if the theta is 180 degrees? We call that straight line or straight angle. Yeah, straight angle to be more precise. It forms straight line. It forms straight line. Okay, but it forms straight line, but the angle is called straight angle. Okay, that's 180 degrees. Now, further terminology, definitions. Angles A and B are complementary if the sum of the angles is 90 degrees. Basically, they add up to 90 degrees. You can visualize it this way. So the angle A, oops, I'm sorry. Angle A here, angle B here, they add up to 90 degrees. Okay, while we say that they are supplementary if the sum is 180 degrees. So when you add those two angles, they add up to 180 degrees. So let's say this is my angle A and this is my angle B. Notice that they add up, forming 180 degrees, making it straight line. Okay. Now, on Monday next week, I will continue on this 5.1. But here's the thing. Maybe I write it as a note here. I write it as a note that after test 2, this Wednesday. I want you to read 5.1 and 5.2. Maybe I ask you to read 5.1 first. Read 5.1, and second, watch lecture video. That I will put on my announcement. So maybe on Wednesday after your test, take a look on the announcement. I have some lecture videos I want you to watch. And then after that, then you read 5.2 further. Okay? So you don't need to worry about this chapter 5 yet until you're done with your test. But right after you're done with your test, you need to worry about this. Okay? Yeah, I think this is where I will stop my lesson. Any questions?